This is Chapter 2, Lecture number 4, and we are on page 20 in the notes. So when we do mathematical calculations, we don't want to just write down what the calculator says. So we have some rules that we use for reporting numbers. If the number to be rounded is 5 or higher, we round up. If the number to be rounded is 4 or less, we keep it the same. So you should pretty much know this one. So if I round 23.89 to 3 significant figures, I would say 23.9. Because we are rounding the 8 up because of the 9 after it. It's greater than 5. If we're going to round 20.04 to 3 significant figures, the actual answer is 20.0. Remember, the 0 to the right of a decimal counts, and we have, therefore, 3 sig figs. When we multiply or divide, the rule is that the answer that you come up with on the calculator, or however you figure it out, must have the same number of significant figures as the measurement with the fewest significant figures. So for number 1, if you did this on a calculator, you would get 6.9124. But because there's only 2 significant figures in 2.2, your answer can only have 2 significant figures. So we round to 6.9. In the second one, once we divide by 2 and then multiply by 2.090, we would get 14.966072. 2.00 has 3 significant figures, so our answer has to have 3 significant figures. So we round, and sometimes this is where it gets tricky, to 15.0. For number 3, if we do the multiplication, we get 110.26. But our final answer can only have 3 sig figs. This has 5. How do you round 110.26 to 3 significant figures? And this is just one of those little rules that we have to know. 110 has 2 significant figures. The decimal at the end makes the 0 significant. When we add or subtract numbers, it's a different rule. In this case, the answer must have the same places as the number with the fewest decimal places. When you finish adding number 1, you get 20.7534. Because 4.3 only goes to the tenths place, your answer can only go to the tenths place. That's a different rule than multiplying and dividing. So the final answer will be 20.8. For number 2, when you add the 3 numbers, you get 39.04755. Because this is a whole number, you can only go to a whole number. So even though you wrote all of that, your final answer is 39. Number 3, when you subtract, you get 46.05. 23.3 goes to the tenths place. Since the number after the tenths is a 5, we round up to 46.1. So this is a quick look at graphing. Graphs are visual displays of data. It helps us to find a pattern that may not be obvious just from looking at a set of numbers. The independent variable we've stated before is what the scientist changes. We plot that on the x-axis. The dependent variable is the variable that changes in response to the independent variable. This is plotted on the y-axis. When you interpolate, you are actually reading a value from the graph. What is the temperature at 300 meters? So we find 300 meters, follow it up to the graph line, follow it to the left, and we see that the temperature will be 18 degrees Celsius. What is the elevation? At 16 degrees Celsius. So we find 16 degrees Celsius, extend it over to the graph line, follow it down, and we see it is at 600 meters. Turn to page 22. When we extrapolate, we extend a line beyond the plotted points. We never want to do this in Regents chemistry. On exams, tests, quizzes, the Regents exam, if you extend past the points you can plot, they will mark you wrong. The following graph shows that the ozone hole is clearly evident over two different time periods. From 1979 to 2010, we can see that it is much lower in total ozone. And that is it for Chapter 2, and we will see you in class.